Hi everyone. I hope all of you are doing well and enjoying the conference. I am Siddharth and I'm part of the Retail India team based out of Bangalore. Today we've already heard about evolution of microservices architecture, the observability and measuring and why milliseconds matter. I'm going to talk about the challenges that come with performance testing in a event-driven architecture and how we solve it for a set of asynchronous APIs. Performance testing and measuring performance are not new. There are many tools in the market which can be used for performance testing and produce fancy reports. APM tools support measuring and tracing performance and have turned it into an art. So then why are we here? From Apache's AB to Gatling to HP's Performance Center, all these tools measure synchronous actions and systems. They do not cover business transactions across business processes. The wait time is not captured, and almost always additional code is needed to set up dependencies between the business transactions. A life cycle of a typical asynchronous business transaction starts with a HTTP request, goes on to from the server responding with an HTTP 202 accepted. The actual processing starts. The asynchronous processing continues even after the response has been sent back to the client. The time taken from the start of the request to the response being received is the HTTP response time. The time taken from the start of the request till the completion of the entire process is the business transaction completion time. All performance tools currently can measure HTTP response time. However, there are no tools in the market which measure the business transaction completion time out of the box. In a load scenario, the request would come in in a load scenario, the different requests would come in, and these requests get processed at different rates. In this scenario, you can see that the fourth request is the one which takes the longest. The last request to complete may not be the last request which was submitted, and this is an important important point to remember. I would also like to introduce a couple of metrics that we monitor. The first one, obviously, being the HTTP response time, the transaction time, the lag, which is the delay from the last request coming in till the completion of the last asynchronous process. We capture the total transaction time, total transaction count, and the total time. The total time is basically the point at which the load generation started till the completion of the last asynchronous process. A business process can be defined as a workflow. And like a workflow, the second stage of a workflow cannot start before the first stage is completed. In this case, we have a create promotion and an approve promotion as a business process. And we cannot start the approve before the creation is complete. As a result, the performance scripts need to keep a track of the completion of the first request before the second request can be executed or fired. To give you a brief glimpse into my world of chaos, when I started, there were three of us, and it used to take us almost 3.5 hours to execute a single load profile. And if the performance was not up to the mark, the team had to look at multiple dashboards across multiple tools, sift through multiple logs in Splunk. And this entire process, being manual, was very prone to human error. For example, if we ran a test at 6 a.m. in UK time, and the developer wanted to look at the database performance, he would have to set 11:30 IST in AppDynamics, since AppDynamics uses the user's time zone. However, if the user was looking at a Splunk dashboard, he would still have to put in 6 a.m. as the time frame, because by default, the time zone which Splunk uses is the UK time. You'll be surprised to know how often developers analyzing a test select the wrong time frame and waste a lot of time coming to an incorrect conclusion. When I joined the team, there were a couple of developers already working on the performance testing. It was very frustrating for me because nobody could explain the entire process and all the steps that were needed. The objective was very clear to me. I had to make my life simple. I wanted to create a tool to enable developers to run performance tests for asynchronous business processes with a single click and be able to look at the right metrics to identify the bottlenecks. To achieve this, we did a couple of improvements. The first one being using of data templates. The data templates are basically files which contain certain placeholders. And we use this, and it makes life easier because we just have to replace a single value every time. For example, for a 5-minute run, we had to create 20,000 promotions and across 7 different types. And using templates made this very easy. We also automated the entire process using shell scripts. We created custom scripts for testing business processes, and we automated the deployment of the microservices and the test scripts, followed by an automated kickoff of the different test profiles. To create or to test the business processes, we used a concept of chaining the scripts together. In this case, the promotion request would be sent to the API, and the response would contain a request ID. This request ID would then be used to get the status of the request. And once the status was completed successfully, the response would contain a promotion ID. This promotion ID was then used to approve the said promotion, and hence completing the entire workflow for a creation and approval of a promotion. We created custom dashboards in Splunk and Grafana. We also created links to these dashboards with the time frame set, so that it became very easy for the user or the developer it became very easy for the developer to actually go to these tools to analyze the test results and uh, look at the bottlenecks. All these links that were created were also provided in a single location. We wanted to ensure observability. We wanted to ensure that observability is present not only in the performance environment, but also in the production environment to enable the SRE teams to identify and fix bottlenecks and problems. To achieve this, we captured a couple of metrics. The first one being the HTTP response time. While in performance environment, we used this data was captured from Gatling's report. In production, we were using Splunk to do the same. The request per second is the rate at which a system can accept the load, was again measured in Gatling and Splunk. The lag was essentially captured in Splunk, and the transaction throughput, which is the rate of completion of the business transactions, was extracted from the database using a query. To allow the investigation of performance bottlenecks, we created dashboards in Splunk. A segment-wise breakup dashboard essentially captures the time for each of the sub-process of the asynchronous process. Advani was used to look at the database queries, the performance of the database queries. We created a concept of a command status, which is essentially which basically tracks each request and captures this time from the start to the end of the request. This is what we used to calculate the entire. This is what we used to calculate the throughput for the service. All these improvements were also wrapped in a performance test pipeline. We checked out the test scripts, deployed the services, ran the performance or the load profiles, and at the end did a cleanup of all the data that was created. We reused a couple of components that were already existing for the deployment of the services. For others, we had to write the scripts from scratch. After a test was executed, we could look at Jenkins to see the performance. We had the Gatling test reports attached to the results. We had the individual results of the test of the load profiles and a consolidated result, which was concatenated for all the results that we had, all the test profiles that were executed. This is the place where we kept all the links for the different dashboards that were created across different services. The only thing that the developer had to do was click on the right dashboard. He could see the dashboard with the time frame set, and hence reducing the chances of a manual error. We automated links for all the dashboards that we had, including specifically for Splunk and AppDynamics. We used AppDynamics for monitoring. The most important part of AppDynamics that we were using was the DB agents to monitor the database. If you look at the screen, selected the query, this query has taken 130 milliseconds to execute, which is very high. We created dashboards in Splunk to capture the overall performance across different services. We created a segment-wise breakup for each service. And with this dashboard, it became very easy for the developers to check where the bottleneck was and focus their energies on fixing that. The journey started with the manual execution, wherein we took almost 10 man-hours to execute one load profile. It was prone to errors. To the current state where we have an end-to-end automation, developers can execute multiple load profiles across with a click of a button. We've executed almost 23 load profiles in a single day. We have scheduled baseline executions to check the performance between yesterday and today based on all the check-ins that happen. In case there is a breach in the profile, in the baseline, we send automated alerts to the team's channel. And this wouldn't have been possible without my team, which included Suyasha and Shiva. We are currently also working on a blog which will cover the implementation in detail. And we are now open for questions.
So I see one on the chat window. You also created a framework of sorts that can be reused by others. Is that possible?
So we have a couple of we have a framework of sorts, right? What we created was very specific, since the workflow for every service, right, is going to be very specific to that service. There is a lot of customization that would be needed, but we are in the process of creating certain examples and creating a library so that this can be reused.
Very much reusable, redeployable. What are you using to drive the automated baseline test? And can that send out alerts after baseline or SLA is breached?
So we do send out alerts after the SLA is breached. That's basically a direct integration between Jenkins and Teams, right? So we have a Teams webhook which we use to send out the alerts. Essentially, the entire process has been automated using a Jenkins pipeline, along with certain custom scripts that we've written. Since we could not generate the kind of load that we wanted to generate, we could not do that on a Jenkins slave machine, right? What we actually do is we log into a VM and uh, execute the test scripts from there, right? So the code and everything is checked out on the VM through the pipeline, but the eventual execution happens through shell scripts on that VM, right? For different profiles, it will continuously happen at multiple times.
Any other question coming in for Sid? How to enforce the definition of a business transaction by consumers?
So I can try to take a stab at that. So the concept of a business transaction is something that is internal to your application, right? So your consumer will initiate the request and want to know when the request is completed, when the processing is completed, because or may not, right? But definitely in your system, you will have a point at which you mark the transaction complete. Now, if the completion has to be reported to the consumer, it could be via notifications, could be via get request, when they just come back and say, is it done? And then you tell them if it's done or not. And then you could use those markers to say that, that's what you want to measure. Obviously, you don't want to expose endpoints, you don't want to expose interfaces that are not required by consumers just for your tests, right? So you basically either make them private or you expose them via a way that doesn't become public. But if you have the benefit of having to notify your consumers that a transaction is complete, then you can definitely sort of utilize those hooks to measure your transactions or to demarcate your transactions. Did that answer the question, Shantanu?
Can you set a framework or setup or framework we used for automated CI/CD integration?
So again, right, it will depend a lot on the ecosystem. We are a set of about 8 microservices as of today, and our CI/CD pipeline actually covers starts from the feature branch, wherein we have a multi-branch pipeline, which would get triggered uh, on every check-in or every commit, right? And then from there, it goes to a pre-dev pipeline, which is basically the same thing, which builds on the master branch, to a integration pipeline, which essentially checks that the different services, the contracts between the different services are still valid and have not broken, right? And this entire process has been templatized to a very large extent, right? So there are improvements that we are doing yes, it can be used to a certain extent as a framework to automate the entire CI/CD process, but there will be components, right, that will have to be customized on top of the framework. The framework cannot work as is, right, because every service is different and every service's requirements are different.
That said, the concepts are the same, right? So you always will want to measure throughput of the at which the system can accept load, as well as throughput at which you can process load. Because for example, let's say that your throughput for accepting the load is 200 requests per second, and your throughput for processing the load is 100 requests per second. Now, if you have a sustained peak load of 200 requests per second for 3 hours, that means that you're going to have the process running for another 3 hours after the load ends, right? And that may sort of impact who your consumers are and when they get the requests that are coming in. So those concepts are the same, right? Your lag, the concept of measuring lag, the concept of transaction or business transaction time, the concept of business process time, concept of chaining and dependencies, all those concepts are the same. And you can apply that in pretty much any context where event driven or async systems are in place. The code is harder to abstract because it depends on the marker that you have for your transactions end. So that's a bit harder, but the concepts are definitely something that can be reused.
Biswa is interested for an implementation demo. So Biswa, if you can probably just connect, you have seen Rajesh and Sid here. You can connect offline to take that demo. Manoj wants to ask a quick one. Can this be used in TDD?
Right. So the concept can be used. So basically, what you would want to do in your tests, and so we have actually done this in our unit tests, in our behavior tests, as well as in our performance tests. Right? The concept is the same. You essentially need to have a marker, and you need to have a notification that is invoked when the transaction starts versus when it ends. And you can actually use that to actually decide whether your process is completed or not. For something at the granularity that we just talked about, basically you would have behavior tests and not unit tests, right? So it would be more like BDD as opposed to TDD. But the concept absolutely is usable. In fact, we have a lot of tests around asynchronous processes and around validating that the way the data comes in, the data that goes out also is correct and is posted to the right to the right destinations using the right contracts with the right data. So the concept can absolutely be used, yes. Though the metrics may not be very relevant.
This one came early in the chat, Rajesh. It is Gatling open source for an enterprise. I don't know if that's directly directed towards you or was that?
Yes, we are using Gatling open source. We're not using the enterprise version.
Are you measuring all the metrics in a life cycle of a business transaction in App Dynamics, Splunk using logs? Example being time to first response, time to last response, etc.
Yes, we are.
Sorry, was a question specifically about Splunk?
No, are you measuring all the metrics in a life cycle of business transaction?
Right, so we're measuring all the metrics, and some of them use Splunk, some of them use App Dynamics, but anything that we want reliable information on, right? We actually use a database. So we actually record all of our, like as Sid had mentioned earlier, right? We have this concept of a command status. The status tracks whether it's complete or not. The status tracks the start time and the completion time, right? It also tracks the errors that may have been there. So we use those command statuses to actually help us define when the test started, when the test ended, when different at different the throughput at the different times during the test, and so on and so forth. So anything that is reliable tends to come from either the load generator or from the database. Anything where we have a little more leeway, like for example segment-wise breakup or stuff that, for example, measurement in production, for that we use Splunk or App Dynamics. But the actual measurement of the transactions themselves come from the database.
Great. This was a wonderful conversation, Rajesh, Siddharth. Thank you so much.